Welcome to this webinar. As advertised, my talk today relates to tools and methods for collecting digital evidence from cloud service providers. My work experience spans more than 20 years, and it covers law enforcement environments and the financial industry. And most of this time I was working as a digital forensic investigator. Some of the discussion points that we'll be going through today is cloud computing. I'll be giving a brief history overview and then drilling down into the challenges that we face. Mobile forensics and how digital or mobile devices could act as conduits to get access to cloud stored data. I'll be presenting some of my tool findings, the benefits of using specific cloud-based tools and the limitations thereof, and also covering what is the future for cloud forensics. Looking at the history, the concept of network-based computing dates back to the 1960s when John McCarthy termed the idea of utility computing, and Licklider created the idea of packet switching network called the Intergalactic Compute Network. Licklider was instrumental in developing the Advanced Research Agency network, also known as APRANET, in 1969. We commonly see that today as the first internet. Although the phrase cloud computing was first used in academic sense by Professor Jelapa in 1997, it would appear that the phrase was only commercially introduced by Google's CEO Eric Schmidt during an industry conference in 2006. Due to sufficient bandwidth and virtual private networks only being offered by telecommunication enterprises from the late 1990s. And in 1999, Salesforce became the first provider of web-based applications, followed by Amazon, which launched its full suite of services in 2006. The International Data Corporation predicted in 2015 that due to the continued growth of cloud computing, it would by 2019 account for almost 50% of total global IT infrastructure spending. As you can see from this graph, that appears to be true. And if you look at the expansion of the cloud by 2022, the global IT infrastructure spend will probably be around 56%. Looking at a quick overview of NIST's definition of cloud computing, network connectivity, it's to a pool of resources consisting of network, server, storage, application. The benefits is really the minimal effort it takes, and the biggest driver is cost. We're looking at this visual model of cloud computing. I think this is the part of every presentation in the cloud. Let's quickly go through it. Characteristics of the cloud. It's on-demand self-service. This characteristic allows the user to provision such services as network storage without human interaction from the cloud service provider. Broad network access. It enables thick and thin clients, that is computers, mobile devices, to act and access cloud services on a network. Resource pooling. Resources of the provider are pooled to provide multiple customers access to resources like storage, processing memory, network bandwidth, using a multi-tenant model. Different physical and virtual resources are assigned and reassigned to user demand. Rapid elasticity. This rapid scalability of resources in accordance with customer demand makes capabilities of provisioning appear unlimited. It's a measured service by leveraging a metered capacity cloud systems could be monitored, controlled, and optimized in accordance with resource usage, therefore ensuring transparency for the service provider and customer. And then we move down to the service models. Software as a service. Applications are offered as services on demand using a subscription or pay-per-use model. The consumer essentially has access to the cloud service provider's application by means of a fin client or application through application programming interface or API. The underlying cloud infrastructure is segregated from customer management and control. Examples of SaaS is Google apps such as Docs, Google Calendar, Google Drive, and Gmail. Looking at platform as a service model, customers-based applications can be deployed on a cloud infrastructure by using the cloud provider's API. The underlying cloud infrastructure, that is network, service, operating systems, and storage, still remains segregated from customer management and control. The customer does have control over the deployed application. An example of PaaS is Salesforce. Infrastructure as a service. This model enables the customer provision and control of fundamental computing resources, such as processing, storage, and networks, thus enabling the deployment of operating systems and applications. The underlying cloud infrastructure, however, still remains segregated from customer management or control. Examples of infrastructure as a service are Amazon Web Services and Microsoft Azure. Moving down to the deployment models, public cloud infrastructure is provisioned for use by the general public and may be owned, operated, or managed by any number of organizations on the premise of the cloud service provider. A private cloud infrastructure is provisioned for exclusive use by a single organization. This infrastructure is usually owned, operated, and managed by the organization. Then we get a community cloud. Its infrastructure is provisioned for exclusive use by customers for several organizations that supports a specific community with shared concerns, for instance, the same mission, security, policy, or compliance. This infrastructure is owned, operated, or managed by an organization itself or third party. We can get hybrid cloud infrastructures. It's a hybrid of two or more of the cloud infrastructures mentioned previously. It remains unique entities bound together by technologies that enable data and application portability. Then just briefly looking at the service models from a different viewpoint. On the left, you get the private on-prem model, and all the way to the right where it is the SaaS model, where the cloud service provider is responsible for all stacks. This slide is just a representation of user awareness. As you can see, the users are predominantly aware of SaaS-based applications such as Facebook, LinkedIn, Gmail, Office 365, etc. They don't really have cognizance of the underlying PaaS or infrastructure service. Looking at who's the cloud role players. As you can see, Amazon Web Services, Azure, Google Cloud, and IBM is probably the biggest role players in cloud. And that should continue for this year going forward. Cloud drivers. Drivers for cloud computing. Cost is obviously the primary driver, but the importance of mobile should not be underestimated. And exactly mobile is the focus area for the digital forensics, as it would provide us an entry point into cloud stored data. Briefly, the definition of cloud forensics. Ruan defined cloud forensics as application of digital forensics science in cloud computing environments. His definition highlighted technical, organizational, and legal aspects. Moving over to the to NIST's challenges for cloud forensics. As you can see, there are multiple challenges. And there's 9 categories that were identified by NIST. We can quickly go through them. First of all, the architecture. It is diverse, complex, and houses multi-tenants, and is prone to data segregation. Data collection, it's difficult to maintain data integrity, conduct data recovery, establish data location, and imaging is extremely difficult. Then analysis, it's difficult to correlate, reconstruct, and time synchronization becomes a challenge. So with consistency with log files, metadata, and reconstructing timelines. Anti-forensics, it's easy to obfuscate data, hiding it, and the risk of malware as well. Incidents first responders, it has a challenge in terms of their response time and reconstruction. Role management, it's difficult to identify data owners, identity management, user access and controls. Legal is also one of the major challenges due to jurisdictions, laws, service level agreements, contracts, subpoenas, international cooperation, privacy, and ethics. Standards, the challenge there relates to the operating procedures, testing, validation, and then lastly, training, specifically training of forensic investigators that has the necessary qualifications and certifications. Digital evidence. What is evidence? It provides it proves or disproves facts. Evidence has 2 main characteristics, namely relevance and weight. Relevance draws a relationship between evidence and the facts under scrutiny and has to be proven by the party representing such evidence. Weight, on the other hand, is the degree of relevance that makes a provision more or less probable. Then digital evidence should be treated no differently than traditional physical evidence. I'm thinking specifically about the chain of evidence. It is, however, a fragile form of evidence that can be easily altered, damaged, or destroyed. This is especially true for cloud computing with its high volatility. Digital evidence continues, evidence must be both relevant and admissible to prove and disprove facts. Admissible evidence meets all legal requirements, such as how the evidence was obtained and handled. Motivation. My personal motivation for conducting these tests it's the fact that cloud computing makes identification of cloud stored data challenging. The prevalence of smartphones using SaaS makes them conduits for identification and collection of cloud stored data. And due to the time is really of the essence due to such factors as the time to live for device tokens. The questions I want to answer, first of all, what user account credentials relating to cloud service provider storage account can be extracted from mobile devices? And then secondly, what digital evidence can be obtained from cloud storage accounts when using a SaaS-based cloud data collection tool? There is related research. As you can see, Quick and Chew already did some research in 2013 when they were using a browser and the cloud service provider's own application. There were some mixed results, although the hashes were collected correctly, so the data was intact. There was alteration on date and timestamps, and the research highlighted the need for dedicated cloud forensic tools. The experiment tests concentrates on the following. First of all, was the tool able to identify cloud service providers and extract any token devices? Cloud data collection was attempted by an automated and manual method. The automated method relates to a token that was extracted, whereas the manual method was conducted by manually entering the account credentials that is known, and then conducting the data verification by means of analysis. The framework that I've followed is one that was drafted by Quick, Martin, and Chu already in 2014. It's, as you can see, it's not a linear process, and it allows for interactive process to divert back to the preparation phase or stage of the framework if any new data sources are discovered during the analysis phase. Then, first of all, the scope of an investigation is the boundaries thereof. If you move outside the boundaries, it is illegal and you potentially risk contaminating any evidence collected. I just want to state that you must have legal authority to conduct any of this data collection methods. In preparation, I looked at the latest versions of the following tools: Celebrite, UFIT Cloud Analyzer, and also the Physical Analyzer, Absa products, XRY, Oxygen Forensic Detective, and Magnets Axiom. I also used a public dataset that's available online for data correctness. Looking at preparation, I created Google Drive and OneDrive accounts, and then uploaded data set to those accounts. I installed Google Drive and OneDrive applications on the iPhone and logged in to make sure that the token is generated and works and it's active. I then created encrypted backups of the iPhone. The first tool that we look at, what data sources, cloud data sources it supports, is Magnets Axiom. As you can see, Axiom supports the basic cloud services such as Apple, Box, Dropbox, Mail, Facebook, Google, Instagram, Microsoft, Twitter, and WhatsApp. Secondly, Oxygen Forensic Detectives adds significantly more data sources. Most notably here, if you have a look at them, is Amazon, Alexa, Huawei, Samsung, Uber, and also WhatsApp. Then looking at the supported cloud data sources for UFIT Cloud Analyzer, it emulates most of the Oxygen Detectives data sources and adds others such as Booking.com. Looking at XRY's supported data sources, it's more in line with those of Axiom's offerings. Moving on to the token identification phase, where really wanted to see if these tools were able to identify tokens on the mobile device. As you can see here from the slide, Magnum did not identify any cloud passwords or device tokens. Looking at Oxygen Forensic Detective, it identified and collected the following device tokens and user credentials: Apple device token, Facebook credentials, Google account, and a OneDrive device token. UFIT Physical Analyzer extracted an account package with Gmail, LinkedIn, that was installed on the phone as well, although it wasn't the aim for this investigation. It did identify LinkedIn and extracted the credentials thereof, and also OneDrive credentials. XRY identified only Google without any credentials captured. Now we move on to the data collection phase. Axiom managed to connect and collect Google and OneDrive data by manually entering the user credentials. Oxygen Forensic Detective collected data from Google and OneDrive using the extracted tokens and credentials. The area that you notice did not interfere with the actual data collection. If you can see that there is a dedicated time or date range available, all these tools have it, so it can really be targeted to what is the scope of your investigation. Moving on to UFIT Cloud Analyzer, it collected data from Google, OneDrive, and LinkedIn using the extracted tokens and credentials. So data was actually collected. And there's a summary of all data collections. So the tools that used the capability to automatically and manually collect data from cloud service providers are illustrated here. It has to be noted that XRY follows an alternative method compared to other tools and relies on the creation of a cloud service provider API in order to connect and collect data. This was not attempted during the experiment, as I tried to emulate the limited time available to forensic investigators on a crime scene. The data analysis phase. Here, Axiom reports the file hashes correctly, but incorrectly defaulted to Unix date and time on the creation, accessed, and modified times. If you can see there on the right top, it tags the data, created data, last access, and modified times as the 1st of January 1970. The data analysis phase for Oxygen Forensic Detective correctly captured files in relation to hashes, dates, and times. UFIT Cloud Analyzer also correctly captured files in relation to hashes, dates, and times. XRY did not capture any data as previously mentioned. Looking at the summary of the data analysis results, all file hashes were identified and the files were found to be correct. In looking at the timestamp information, Oxygen Forensic Detective and UFIT used the local time as opposed to Axiom that defaulted to UTC time. So that must always be taken into account to make provision for that. Again, I just noticed that Axiom incorrectly captured those creation dates. Looking at some of the benefits of using SaaS-based tools, it really narrows the scope down by only acquiring content of a specific date and time. There's no need for seizure of a shared cloud resource, so you don't have to go and seize the hardware of a cloud service provider. Validation of digital evidence is possible with these tools. It mitigates the risk associated with time-consuming legal process. You can still run the legal process in parallel to using these tools. It limits interaction with and dependence on cloud service providers. And probably the biggest benefit is that it uses the local keys of the device to bypass encryption. Then just highlighting some of the limitations. Not all cloud service providers are supported. The tools vary in their support for cloud service providers, as you've seen. So choose your tool wisely. 2FA is always an additional challenge, and it will most probably mean that you'll have to have the original device handy for that 2FA. API creation is, it adds to the data collection process, it adds time if you have to create an API. And then transparency is lacking as far as cloud service provider log creation goes. This would still require that you interact with the cloud service provider to get that detail. The future of these tools, and for cloud forensics, most probably a forensics as a service. This could benefit digital forensics in relation to its elasticity and computing power of cloud computing, where you can add huge resources to index and to analysis much quicker. Digital forensic tools such as FTK is already cloud capable. And in the future, you'll definitely require more support for additional cloud service providers. In conclusion, my first question relating to token identification and transaction from iPhones varies from tool to tool. UFED physical analyzer and oxygen forensic detective were successful. My second question relating to the manual data collection was successful with UFED Cloud Analyzer and Oxygen Forensic Detective. Both tools collected Google Drive and OneDrive data. Thank you for listening to my talk. I'll take any questions now. Thank you.